Good day, learners. Welcome to our physical sciences lesson. My name is Amin Mkize. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Right, grade 11s, welcome back. It's so exciting to meet you again. So we are doing physical sciences. Remember, when it comes to your physical sciences, you have your physics, which is your paper 1, and you have your chemistry, which is your paper 2. So our focus for this lesson, it's physics, and then under physics we are going to focus to knowledge area mechanics, and then under mechanics we are going to focus on vectors in 2 dimension, right? Then I believe all of you learners, you have what we call the examination guidelines, either the hard copy or the soft copy of the examination guideline for grade 11, so that you'll know what we are supposed to cover under vectors in 2 dimension. So according to our exam guideline, this is what we need to cover under vectors in 2 dimension, resultant of vectors. And I believe it's not the first time you meet this term resultant. You did this, I think it was term 3 last year in grade 10 under mechanics. So actually here is just the continuation of what you did last year, or it's just the addition of what you did last year. Right, so under vectors in 2 dimension. So remember you did vectors in 1 dimension in grade 10. Right, you calculated the resultant vector of vectors in 1 dimension. So this year you will be focusing on vectors in 2D, right? So under resultant of vectors, it should be 1 definition of the resultant. You should know what is the resultant, right? So at the end of this lesson, you should know how to define the resultant or the resultant vector. Okay, right, determine the resultant of vectors, the maximum of 4, on a Cartesian plane using the component method. Find the vertical and horizontal components of each vector and add collinear vector vertical components and collinear horizontal components to obtain resultant vertical vector and the resultant horizontal vector, right? Then sketch the resultant vertical vector, which is your ry. Ry, this stands for resultant for vertical vector, and then the resultant horizontal vector, which is the rx, which stands for the resultant for horizontal vectors. Then calculate the magnitude of the resultant using the theorem of Pythagoras. Determine the direction of the resultant using simple trigonometric ratios. Determine the resultant of 2 vectors graphically using either the tail-to-head method or the tail-to-tail method, right? And then explain the meaning of the closed vector diagram, and then resolve vector into its components. For example, if a force or a vector is applied at an angle to the horizontal, you must be able to resolve that vector into its components, which is the vertical component and the horizontal component. So this is what we need to cover and vectors in 2D. So you did vectors in grade 10, right? You by now, I believe, you know the difference between a vector and a scalar, right? So, but just to remind you of what you did, of what you did last year, ne? What is important here? It's these terms. Right, you should know what is a physical quantity, a scalar, a vector, a resultant vector, a closed vector diagram, and also the equilibrium, right? For you to be able to understand, what we are going to do under this topic, all right? So 1, a physical quantity, which is what you did in grade 10. So a physical quantity is a property of a material or a system that can be quantified by the measurement. So anything that can be measured, that is the physical quantity. For example, when you talk of scalars, vectors, those are physical quantities because they can be measured, right? So a scalar, right? So a scalar, we define a scalar as a physical quantity. So we are here as the physical quantity with magnitude only. So please, my learners, when it comes to a scalar, right, don't get confused, because in most cases when we talk of magnitude, learners, they only think of a value, right? So when we talk of magnitude, it should be the value and the SI unit. For example, an example of a scalar, if you still remember from grade 10, speed is a scalar, right? And what is the SI unit for speed? It's meters per second. So you can't say the speed of this object, or the speed of a car, for example, is 50 watt. It should be 50 meters per watt per second. So that is the magnitude. So the magnitude is the value and the SI unit. So very, very important. Don't just think of the value when you talk of the magnitude. So it's the value and what, and the SI unit. For example, 5 degrees Celsius. So that is the magnitude of the temperature, right? 5 meters per second, that is the magnitude of what? Of the speed, right? 5 meters, that is the magnitude of the distance, okay? Right, so those are some of the things that you need to be careful about, because when you talk of the magnitude only, they think of the value. It's not just the value, it should be the value and accompanied by what? By the SI unit. So that is a scalar, right? By now, I think you know examples of scalars. For example, already I've mentioned a few: the temperature, the speed, the distance. So those are the examples of what? Of scalars, right? Then a vector that is also a physical quantity, but this one is a physical quantity with magnitude and what? And direction, right? So when it comes to a vector, there's magnitude and what? And the direction. So magnitude and direction, it means that, for example, when you talk of velocity, remember, it's a vector, right? So when you give the final answer, let's say the question says calculate the velocity of this object, or what is the velocity of this object, all right? So then you'll say, for example, 5 meters per second east, right? So is the value, magnitude, and the direction. 5 meters per second, that is the magnitude, and then the direction will be what? Easterly what? Direction, for example. So that is a vector, a physical quantity with both magnitude and what? And the direction, right? Then when it comes to a resultant vector, I'm doing this because it's not the first time you define these terms. So it's just a reminder of what you did last year. So the resultant vector, so a resultant vector is the single vector that having the same effect as two or more vectors acting together, right? So that is the single vector that has the same effect as other two or more vectors acting together, right? So that is the resultant vector. So but moving forward, we'll talk more about that, so that you understand when you talk of a resultant vector, what are we talking about. But remember, again, in grade 10 you did look into that, all right? Then when it comes to the closed vector, a closed vector diagram. So a closed vector diagram is a set of vectors drawn on the Cartesian plane using the tail to head method, and has a resultant with a magnitude of what? Of 0. This is very, very important when you define a closed vector diagram. So that diagram, so if, for example, you are dealing with forces, right? So when you draw, the diagram of those forces, or the vector diagram, right, then you should know that the resultant there will be will be 0, right? So those forces, they will form a closed vector diagram. So they will form a closed vector diagram. So if they form a closed vector diagram, then you should know that the magnitude of the resultant there is equals to what? 0. But you'll see what we are talking about. So a closed vector diagram, what forms a closed vector diagram? Those are vectors that are at equilibrium. So we'll talk more about that. So what forms a vector diagram? Those are forces that are at equilibrium. And if we say forces are at equilibrium, you should know that their resultant is equals to 0, or the magnitude of the resultant is equals to what? 0. Right. So then another thing when it comes to vectors, right? So I'll just go back. When it comes to vectors, what is important? Remember, when you define a vector, we say a vector, it's a physical quantity with both magnitude and what? And the direction, right? So The issue of the direction there, again, learners, is very, very important, all right? So the different method or ways in which we can give, the direction of what, of a vector, okay? So one of those ways in which we can give the direction of what, of a vector, it's the bearing, right? So let's start with this one. It's also very, very important when it comes to giving the direction of what, of our vectors. Remember, vector, it has both magnitude and what, and the direction. So when it comes to the issue of the direction, right, there's different ways in which we can give what, the direction of what, of a vector. For example, the first one will be the bearing, right? So when it comes to a bearing here, you are given what, vectors here, or rather forces, right, that are on, or that are drawn on a Cartesian plane. So it's this one is the first one, which is the angle here. I hope you can see the angle here is 60 degrees. And then that is the first vector with the magnitude of 10 newtons. There's the second one here. And then the angle here, it's they're saying it's what here is 292. So if it's 292, let me just check something here. So it's 292 minus 180. So that we don't, so it's 292. So not 292, but it's 192. 192 minus 180. So which means that here actually, from 180 to this force, it's actually 12 degrees here. Yeah, that is the angle. So it's 12 degrees. So let's check. This one is 335. 335 minus 270. So here I'm having what, 65. So it's better if I'm going to give you these values, right? So now I don't think we can have a problem when it comes to the magnitude, but the problem here will be the direction, okay? So when it comes to using bearing for the direction, right? So you have your Cartesian plane, right? So here you have the compass directions, for example. So you have your north at the top there, all right? So you have your north, you have your east this side, you have your south this side, you have your what? Your west, okay? Right. Then your north becomes 0 degrees, right? And then when you count clockwise, right? So you move in the clockwise what direction, which means here it will be 0, and then where you have east, you have what? 90 degrees, and then where you have south, you are having what? 180. You can see that even here there's 90 for east, and then for south it's 180 degrees, and then for west it's 270 what? Degrees, right? And then obvious here it will be what? 360, the full cycle, right? So it will be 360 degrees, right? So when you count, right, you move clockwise. So your reference point here, it's north. So north becomes your 0 what? Position, okay? So north will be 0 degrees, move to east, it's 90, move to south, it's 180, and then you move to what? West, that is going to be your 270, right? Then let's look at the first one, right? So the first one, it's FA, right? So the magnitude is 10. So the magnitude will be what? Will be 10. So FA, the magnitude is 10 what? Newtons. So I've given the magnitude. Remember, when you talk of the magnitude, right, is the value and the SI unit. So that is the magnitude. So what is missing here, it is the direction, because force is a vector. So vector, it has both magnitude and what? And the direction. Then the direction, and then the method that we are using to give the direction of this vector is bearing, right? And bearing, let's not forget, the reference is north. North becomes a 0 position, so it's 0 degrees, right? Then from this, from north to this force, which is your FA, what is the angle between north and FA? Is 60 degrees, right? So you can say 10 newtons at a bearing of 60 degrees. So already you have given the direction there. bearing of 60, that is the what? The direction. Then 10 newtons, that is what? The magnitude. So it's 10 newtons at a bearing of what? Of 60 degrees, right? If you're using bearing. Then let's look at FB. So FB, the magnitude is 80 newtons. So our FB, what is the magnitude of FB? It is 80 newtons, right? At a bearing of what? So from north, your reference, remember, if you're using the bearing, your reference it's north. So north becomes your zero position. So you're moving from north up to FB. All right? So from north up to FB. So from north up to FB. So from north to east, that is 90. And then from east to south, that is 180. Then from this 180 to this FB force, right, you have 12 there, right? So you have 12 degrees. So you are going to say 180. So from here to here, it will be 180 plus 12. Okay? So what is 180 plus 12? 180 plus 12, it's what? It's 100 and what? And 92. So it's at a bearing of 192 what? Degrees. Simple, I think so, right? Because you always start from north and then you move clockwise, right? So north becomes your zero position, or it becomes your what? Your 0 degrees. So from north up to this FB force, it's 192. How did you get that 192? So from north to south is 180, right? You can see it forms what? A straight line there. So the angle will be 180. So we'll say 180 degrees plus 12 degrees, which is what? 192 degrees. Okay? Then let's move to FC, force number 3 there. The magnitude there is 5. So we'll say it's 5 newtons, right? At a bearing of what? So you are moving from north, no shortcuts, right? So you are moving from north and you move clockwise. So you move clockwise up to that force, right? So between 270, right, which is your west, and this force, what are we having? The angle there is 65, right? So you have to say 270 plus what? Plus 65. Right? And what is 270 plus 65 is 300 and what? And 35. Then we'll say at a bearing of 300 and what? 300 and what? And 35 what? Degrees. Simple. Ne? So that is one of the methods that you can use to give what? The direction of what? Of a vector. So we can use what? Bearing. Right. Then there's another one where you can use maybe the compass directions, okay? So where you can use what? The compass what? Directions, your north, your south, your east, your west, right? Okay, so you are having the first one here, right? Then your FA, the magnitude is 10 newtons, and then you can see the angle between east and this force, right, is 30 degrees, right? So this one will be, if you're using the compass directions, it will be FA equals to 10 newtons, right? What is the angle between what this force and east there? It's what? It's 30, right? So you can say 10 newtons, 30 degrees, right? And you can see your FA, it's between north and what? And east. All right? But this 30, right? So your FA is between north and what? And east. Okay? And then this 30, where is this 30? Right? This 30 is between this force and what? And east. Then we can say 30 what? North of what? Of east. If we say of east, it's like you're saying from east. So from east, where is this force, right? So this force is 30 degrees from what? From east, right? So hence we say 30 degrees north of. So it's from, is what? Is from east. So it's 10 newtons, 30 degrees north of what? Of east. Okay? So let's look at FB. FB equals to what? 8 newtons. What is the angle given there? Is 12. But that 12 we can see is from what? It's between, actually it's between what? Your FB and south, right? So we are counting 12 degrees from south to that FB. So you're counting what? 12 degrees from south, right, to that FB. So then the force, remember, is between west and what? And south. So we'll say 12 degrees west of south. So if I say of south is from, so I'm counting 12 degrees from south. Okay, so it's 12 degrees west of what? Of south. Ne? Then let's look at FC. FC will be what? You can see your FC, it's between west and what? And north. Okay, but where is this 65, right? So this 65 is between west and FC. Okay, so the magnitude here is 5 newtons. What is the angle? It's 65. But this 65 is from what? Is it from north to FC or from west to FC? It is from west to what? To FC. So hence I will say of what? Of west. So it's going to be what? 65 degrees, right? North of what? Of west. Okay? So I hope it's making sense. So we can also use what? The compass directions. Then the angle here, if you are having 30 here, right? So moving from north to east, remember it's 90. So those two, they're perpendicular to each other, right? So if here is 30, here is what? It's going to be what? 60, right? So if here is 60, right? So I can say my FA actually here, depending on the angle that is given there. I can say my FA is 10 newtons. What is the angle now? It's 60 degrees. But 60, you are counting 60 from what? Is it from north or from east? It's from north. So we will say of what? North. So it's from what? It's from, that's 60. I'm counting 60 from what? From north. Right? Hence I will say of what? North. From what? North. I'm counting 60 what? Degrees angle. Right? Then it's going to be what? East of what? Of north. Okay? This one, if here is 12, all right? It means that here is going to be what? 70 what? 78 degrees. Therefore, your FB will be what? 8 newtons. What is the angle? 78 degrees. But you are counting that 78. Is it from west or from south? It is from what? From west. So from west to this FB, it's 78. So it's from what? West. Hence here I will say of what? Of west. So it's going to be what? South of west, because that force of 8 newtons is between west and south. Okay? But I'm counting 78 degrees from what? From west to that force, or to that FC. Okay? Then let's look at our FC. If here is 65, so 90 minus 65, I'm having what here? It's going to be what? 25 degrees, right? Which means that my FC will be what? What is the magnitude? 5 newtons. What is the angle given? Is 25 what? Degrees. So that 25 degrees, is it from north to FC or from west to FC? It is from north to FC, right? So if it's from north to FC, hence here it means that I will say of what? Of north. Because that 25 is from north to what? To FC. Okay? Then of north, which is going to be what? West of what? Of north. So this and this is the same thing. Okay? This and this is also the same thing. Even the last one is also what? The same thing. Okay? So that is how we can give the direction of a vector using what? The compass what? Readings, or the compass what? directions. I hope it's clear, right? Then we can also use the Cartesian plane, right? In mathematics, you are aware that when it comes to the Cartesian plane, right? Okay, when it comes to the Cartesian plane, I think it's better if I'm going to do this, right? This is your Cartesian plane. Here, you have your positive y-axis, right? You have your negative y-axis. You have your positive x-axis. You have your your negative x-axis. Okay? Then you have this force, Fa, with a magnitude of 10 newtons, right? And then here you are given 30 degrees. Okay? So using the Cartesian plane, right? You can give the direction using the Cartesian plane. For example, look at your Fa. What is the magnitude of Fa? It's 10 newtons, right? What is the angle given there? Is 30. Okay? So if it's 30, so this 30 is 30 above the positive x-axis. You can see that 30 degrees above the positive x-axis. Yeah? 30 degrees above. You can see that this is 30 degrees above the positive x-axis. Or if here you are given 60 degrees, right? You're going to say my Fa is going to be 10 newtons, that is the magnitude, right? At an angle of of 60 degrees, right? Of 60 degrees to what? Now the focus is the vertical y-axis. Okay? So it's the y-axis. So remember, this 60 degrees is between Fa and and the y-axis. And which y-axis? The positive y-axis. Okay? So it's going to be 60 degrees left of negative, sorry, not negative, but positive y-axis. Right? So these are your y-axis. But actually here it shouldn't be left. So it should be right. Sorry about that. So here is 60 degrees right. It's on the right. So this is right, this is left. So this side you have right, and then this side you have left. So it's 10 degrees, 60 degrees right of the positive y-axis. Okay? Then let's move to the second one, right? Which is your FB. Here you are given 12 degrees. Okay? Then the magnitude of this one is 8 newtons. So therefore your FB will be 8 newtons. What is the angle? Is 12 degrees. Where is this 12 degrees? This 12 degrees, is it along the y-axis or the horizontal axis, which is your x-axis? It's along your your vertical axis, all right, which is your y-axis, right? So 12 degrees left. So left of negative y axis. Okay? The last one, what am I having there is FC with a magnitude of of 5 newtons, right? Of 5 newtons. So my FC will be what? What is the magnitude? 5 newtons. The angle given here is 65, right? So it's going to be at an angle of 65 degrees left, or not even remember, you're using left, right for the vertical axis, ne? And then we are using above or below, right, for the horizontal axis. So here it will be 65 degrees above, right? So above the negative x what axis. So you can see it's above. These are your x-axis. So this 65 is above the negative what axis or x-axis, ne? And then this 30 again is above the x-axis, ne? But it's above what? The positive what? X-axis, right? Then this one, if I can include another one here, right? Here, remember, it's 78 what degrees. So for your FB, I can say my FB, right, is equals to what? The magnitude is 8 newtons. What is the angle given there is 78 what degrees. And can you see that this 78 is between the horizontal axis and this force, which is your FB, right? Then is it above or below the horizontal what axis? It is below. So 78 degrees below what? Positive or negative? Is below what? Negative x what? Axis. So 78 degrees what are below what? Negative what? X axis. Okay, so there's a question here. Do they always tell you above the positive y axis? Okay, I want to get this one. We are saying, do they always tell you above positive y axis? Okay, so here, learners, I don't want you to get confused, right? So just choose a method that is going to work for you, right? But I think at the beginning, you should know all different, ways or methods that we can use to give the direction of what? Of a vector. Okay. So here, I'm using what? The x-axis and the y-axis, right? So remember, we have positive x-axis, negative x-axis. So what is important there when we are using the x-axis, all right, is either, right, the angle will be above or below the x-axis, right? It's either it's going to be above or below the x-axis. So for example, when you look at this 30 for FA, it's above the x-axis. But which x-axis, is it the positive or the negative? It's going to be the positive. When you look at this 78, this 78 is below the x-axis. But which x-axis? Is it positive or negative? So it's below what? The negative x-axis. When it comes to the vertical axis, which is your y-axis, right? So below, we are using left or right. There's no below and above. Below and above is for the horizontal axis, right? And then left and right, it's for what? Is for the vertical what? Axis. For example, here, I'm having what? Right? I'm having what? 60. Right? So this 60, is it 60 right of what? The vertical axis or left? Right? So right, left. Another thing which is important here, if this is your y-axis, ne? This is going to be right of this line, right? And then left of this line, which is your vertical axis. All right? So if it's this side, then that is left. If the angle is this side, that is going to be what? Right. Okay, that is very, very important. Okay, so please be careful when we are using the Cartesian plane, the y-axis and the what and the x-axis, right? So x-axis is either above, the angle is either above or below, right? Okay, it's either above or below the positive x-axis or the negative x-axis. When it comes to the vertical axis, which is your y-axis, it's either the angle is to the right or to the left of the positive y-axis or the negative what? Y-axis. So that's it. So you choose the method that is going to work for you. So I hope you understood the three methods: the bearing one, the compass one, and also what the one of the Cartesian plane. All right. Then now let's look at the resultant of collinear and perpendicular what? Vectors. Okay. Right. So what is important here, learners, is for you to understand what are collinear vectors and what perpendicular what vectors. I think we should start there. All right, but again, already remember you did talk about what the resultant in grade 10. You already know what is the resultant. You know how to find the resultant of vectors along a straight line or vectors in one dimension. Okay, right. Then, right, let's start with a collinear vectors. What are collinear vectors? So collinear vectors, those are vectors that are acting along what? A straight line. Those are collinear what? Vectors. So when you talk of collinear vectors, those are vectors that are acting along what? A straight line. For example, when you look at 35 newtons, so let's say this is your F1, this is your F2, this is your F3, this is your F4. So your F1 and F2, you can see they're acting along a vertical straight line, right? So these are collinear what? Vectors, right? Linear means straight, right? So collinear what here? Vectors, right? So please be careful if vectors are acting along a straight line, right? For example, although your 135 is acting upwards and then your 45 is acting downwards, but they are along a vertical straight line. Therefore, they are collinear what? Vectors, right? Look again, your 60 newtons and your 275 newtons. They are acting along a horizontal straight line. So these are also what? Collinear vectors, right? So these are also collinear what? Vectors. So collinear vectors, those are vectors that are acting along what? A straight line. Okay, vectors acting along a straight line. It doesn't matter whether, even if they're acting in opposite directions. So look at your 135 and your 45, your 60 and your 275. They're acting in opposite directions, but they're acting along a horizontal what? Straight line. Therefore, we call them collinear what? Vectors. Okay, then what are perpendicular vectors, right? So perpendicular vectors, those are vectors that are acting at right angles to each other, right? So those are vectors that are acting at right angles to each other. So those are perpendicular what? Vectors. For example, when you look at your another thing which is important here, if we say something is perpendicular, it means that or if we say vectors are perpendicular, let me not say something. So here we are referring to vectors. So if we say vectors are perpendicular to each other, it means that those vectors, what are the angle between those vectors? It's 90 degrees. So hence we are saying they're acting at right angles to each other. So a right angle, it's an angle with a magnitude of 90 degrees, right? So for example here, from this point to this point, from 135 newtons to 275 newtons, right? So the angle there is 90 degrees, right? So if it's 90 degrees, it means that they are perpendicular to each other, right? So therefore 135 degrees and 275 degrees, they are perpendicular what? Vectors, right? Same with 275 and 45. They are perpendicular vectors. They're acting at right angles to each other. So the angle between them is 90 degrees. Same with 60 and 45 newtons. They are perpendicular to each other, right? And then same with your 135 and 60 degrees. They are also perpendicular to each other. So what are perpendicular vectors? Those are vectors that are acting at right angles to each other. So what the angle between those vectors is 90 degrees. So we call them perpendicular what? Vectors. So what are we going to do now is to find the resultant of these perpendicular what? Vectors. Our focus, remember, is vectors in 2D, right? So 2D, it means that those are vectors they are perpendicular to each other. Collinear vectors, they act along what? A straight line. So those are vectors in one dimension. For example, your 60 and your 270, these are vectors in one dimension. They're acting along what? A straight line. They are collinear vectors, right? Vectors in 2D, those vectors are perpendicular to what? To each other. So hence we call them vectors in two dimension. Okay, so vectors in two dimension, for grade 11, those are perpendicular what vectors. Okay, then now let's look at how do we find the resultant of perpendicular forces, or perpendicular what in this case it's forces, or to say perpendicular what vectors. Okay, so first thing that we need to do here, we want to find the resultant of these 4 vectors, right? So there are not 4 vectors or 4 forces, right? So there are 4 forces that are acting on this object. It's 135 newtons, it's 275 newtons, and the 45 newtons, and the 60 watt newtons. So they're acting on this object. So we want to find their resultant, right? So we want to find the resultant of these 4 vectors. Where are we going to start? So already we know how to find the resultant of vectors acting along a straight line, or the collinear vectors. That's what we did in grade what? In grade 10. And we can find that either by calculations or by by scale drawing, okay, using either the tail-to-tail method or the tail-to-head what method. That is what we did in grade what? In grade 10, in term 3, right? So first thing that we need to do, we need to check in your diagram, do we have collinear vectors there, or forces, right? We can see we have collinear. So first thing that we need to do is to find the resultant of those collinear vectors, right? And from there, find the resultant of those perpendicular what vectors. This is where we have to start, right? So determine the resultant of collinear forces, right, or vectors. So these are the 2 vectors that are acting along a straight line, right, which is your 60 newtons and your 275 watt newtons. We want to find their resultant. So we want to find the resultant of horizontal what forces, right? So this is going to be our Rx, ne? And to find the resultant, remember, for vectors along a straight line, or for vectors in one dimension, or for collinear vectors, right, the equation that we use, right, is going to be what? Rx, which is the resultant of forces that are acting along the horizontal surface, right? So it's Rx, which is going to be what? A resultant name, which is going to be what? Rx1 plus what? Let's not use resultant because we are going to get confused. So Rx, we are dealing with forces here. So it can be Rx or FRES, because we are dealing with what? With forces. So FRES, which is the resultant force, or the resultant of forces that are acting horizontally. Okay, then is FRS, which is going to be what? F1 plus what? F2. Okay, then remember, force is a vector. Okay, so what is important here is to make sure that you choose what? The direction. Okay, so for example, in this case, you can see they took right as what? As positive, and then they took left as what? As negative. Okay, okay, or they took west. This can be west, this not west but east. This can be east, and then this can be what? West. So they took east as what? If you're using the compass directions, so they took east as what? As positive, right? So what is the magnitude and direction here for this force? Is 275 newtons east, right? 275 newtons east, or at a bearing of what? 90 degrees, because you will have your north there, then he is going to what? 90 degrees. What is the magnitude of this one? It's going to be, it's not negative 60, right? But it's going to be 60 newtons west, or at a bearing of what? Of 270 watt degrees. So you can see that these 2 forces, they're acting in opposite what? Direction. So let's choose direction. We take in this case they're taking east as positive. Hence here you see positive there. And if east is positive, it means that west is going to be what? Negative. Okay, because they're acting in opposite what? Directions. So if east is positive, west is going to be what? Negative. So here it's going to be what? F rest or resultant force will be F1. Your F1, it can be 60 or 275. Ne? So it's going to be what? 275 plus. But this other force is acting in the opposite what? Direction. So it's plus into minus what? Minus 60. And then the answer there is what? Is 215 what? Newtons. But it's 250 newtons in which direction? 250. You got a positive answer. And you took east as what? As positive. So if you're getting a positive answer, therefore, the final answer will be what? 215 newtons in which direction? East, because your final answer was positive and you took east as what? As positive. If your answer was negative but you took east as what? As positive, therefore your direction was going to be what? West, because if east is positive, then west is going to be what? Negative, right? So for the first one, we are having what? 250 newtons in which direction? East. That is the resultant for horizontal forces there. That is the resultant for horizontal what? Forces. Now, let's move to the resultant for the vertical forces. For the vertical forces, you have 135 and 45. So in this case, they are taking up as positive or north. You can say north there, then this one would be what? Will be south. So they're taking north there as what? As positive. So your Ry, which is the resultant for vertical forces. Ry is the resultant for vertical what? Forces. Or you can say F res for what? For a vertical what? Axis. Ne? Then again it's going to be what? F1 plus what? Plus F2. So which direction did they take as positive here? It's north. So your north will be what? Positive 135 plus into. If your north is positive, then what about your south? Your south is going to be what? Negative. So it's negative what? 45. So what are we having here is 90 newtons. But can you see your answer is positive, which means that, remember, you chose north as positive. It means that here is going to be 90 newtons in which direction? North. All right? So that is what you need to do. Remember, you want to find the resultant of all those four forces that are acting on that object. Ne? So, but you can see for your vertical forces, it's not only one force, but it's how many forces? Two. So first thing that you need to do is to find the resultant of vertical forces, right? Because it's more than one. But if it was one, there was no need, right? But it's more than one. Therefore, you need to find the resultant of the vertical forces. Same with the horizontal forces. If it was only one, there was no need of what we did. But we are doing this because you can see there are two forces that are acting horizontally. So first thing that we need to do is to make sure that we get their resultant. Okay, then find the resultant of the vertical forces, find the resultant of the horizontal forces. Simple. What is very, very important is to make sure that you choose what? The direction and substitute accordingly. Okay. Then from there, now we are left with how many forces? Two. We are left with 90 degrees north and also what? And also this one. 250 newtons in which what direction? East. So it's what we are left with. So we are left with 90 newtons in which direction? North. You're also left with what? Rx, which is the resultant of horizontal forces, which is 215. So now, can you see we are only left with these two, which is Ry and Rx. Please don't get confused. Rx is the resultant for horizontal forces, and then Ry is the resultant for vertical what? Forces. Okay. Then now it's what you are left with, your Ry and your Rx. Then in this case, learners, you can't say the resultant now of these two will be Ry plus Rx. Remember, your Ry and your Rx, they are not acting along a straight line. They are not collinear. So collinear, we add F1 plus F2. But again, don't forget the issue of what? Of the direction. So for vectors along a straight line, to find their resultant, we just add, right? So it's F1 plus F2, but take into consideration the issue of the direction there, okay? If they're acting in opposite directions, the other one will be positive, the other one will be what? Will be negative, okay? Then we can even use the compass, right? What is this? The Cartesian plane, right? So for example, in this case, you have your what? In this case, if I can draw a Cartesian plane here, I'm having positive y-axis, negative y-axis, negative x-axis, and positive what? X-axis. So I can take this what? West, not west, but east as what? As positive, because that east is along the positive x-axis. All right. I can take this as what? As negative. Or I can take west as what? As negative, because it's along, you know, the negative x-axis. I can take north as positive because it's along the positive y-axis. I can take south as negative because it's along the negative y what? Axis. So those are some of the things that you can do. But again, for this what scenario, there's no way that you can just say the resultant of these two perpendicular forces, it's going to be what? Ry plus Rx. We don't add if those forces are not along what? A straight line. What do we do if forces are perpendicular to each other? All right. So if forces are perpendicular to each other and you want their resultant, okay, how are you going to get their resultant? Very, very important. You did maths, right? And your maths is good. You still remember the theorem of what? Of Pythagoras. So for forces or vectors that are perpendicular to each other, to get their resultant, we use Pythagoras theorem. By calculations, we use Pythagoras what? Theorem. So in this case, it will be your what? Your resultant squared equals to what? Your Rx what? Squared plus your what? Ry what? Squared. Resultant of a perpendicular what? Forces will be Rx squared plus what? Your Ry what? Ry squared. That is the Pythagoras what? Theorem. Okay? So hypotenuse side equals to what? The adjacent side plus what? The opposite side. Right, then which is the same as what? As R equals to the square root of Rx what? Squared plus what? Ry what? Squared. That is the Pythagoras what? Theorem. Then what am I having here is the square root of what? What is my Rx? Is 215 what? Squared. Whether this 215 is positive or negative, but at the end I will get a positive answer because of that square. Okay? Right, plus what is our Ry is 90 what? What here? Squared. Okay? So then you'll get what? The magnitude. So what are we getting here? The answer here will be what? 200 and what? And 33.07 what? Newtons. Okay? So it's 233. So, but you can see where they started. Okay? It's R squared plus Rx squared plus 250 Ry squared, which is 215 squared. Okay, so the answer there is what? Is 233.07 what? Newtons. So when you use the theorem of Pythagoras, the only thing that you'll get for that resultant, it's only the magnitude. Then the direction, you have to use the trigonometric what? Ratios or the trig ratios. Okay, how do you use trig ratios? Go back to your diagram. Okay, before that, there's a question here. Do we choose the direction when not given in the question? Perfect. We have to. We have to. Remember here, we are dealing with what? With vectors. Okay, we are dealing with vectors. Okay, so if for example, you are told that because okay, based on what you are saying to me, let's say you are just given what a diagram like this. This is the diagram, right? For example, in this case, you can see you are not given the direction. So there are three ways in which you can give the direction of a vector. So it's up to you. Here you can use bearing. If you are using bearing, for example, this one will be 135 newtons at a bearing of 0 degrees. This one will be 275 newtons at a bearing of 90 degrees, 45 newtons at a bearing of 180 degrees, 60 newtons at a bearing of 270 degrees, right? Or you can use what the compass what directions. This one will be 135 newtons north. Okay, this one will be 275 newtons east. This one will be 45 newtons in which direction? South. This one will be 60 newtons in which direction? West. So please make sure that you give direction of those forces or direction of those what vectors. So by now you know all those different what methods that you can use or ways in which you can give the direction of a vector. So that is very, very important. So do we choose the direction when not given in the question? Yes, we should do that, because we are dealing with what? With forces or with vectors here. All right. Then from here, after using your theorem of Pythagoras, but remember we use that theorem of Pythagoras for perpendicular vectors. If vectors are perpendicular to each other, to get the magnitude of those perpendicular vectors, you have to use the theorem of what? Of Pythagoras. Perpendicular, the angle between the two forces, the angle between the two vectors should be 90 degrees. But in a case where you have something, where you have something like this, this is your FA, maybe this is your FB, and let's say the angle is 30 degrees. You can't use the theorem of Pythagoras there to find the resultant of FA and FB. Why? Because those two forces, they're not perpendicular to each other. Okay? So you use theorem of Pythagoras if forces or vectors, they are perpendicular to what? To each other. And when you use that theorem of Pythagoras, you will only get the magnitude of the resultant. How do we find the direction of the resultant now? Okay, so to find the direction of what? Of the resultant, we have to use the trig ratios. How? So I think we are fine with the magnitude of the resultant for perpendicular vectors. Right? Go back. You have these two forces. Right? You have your Ry and your what? Your Rx. Okay? So one of the methods that you can use, just draw a rough sketch, right? What of the resultant, what and these other two forces using the tail to tail method. Ne? So you can see that these two forces are drawn tail to tail. Okay, this is the tail, remember, and then this is the head where you have the arrow. So they're drawn tail to tail. You can see that. Okay, then what you need to do, you complete the diagram. So this is still what? Your Rx. This is still your what? Your Ry. Okay, this is the parallelogram what? Method. Forces drawn tail to tail. Okay, then from here, how do we draw the resultant? Okay, how do we draw the resultant? Resultant is drawn from two tails to two heads. So this is how we have to draw what? The resultant. It's just a rough sketch. Okay, then I will talk to that. How do you determine which trig ratio you should use? So I'm coming to that. Okay, but I think it's clear. To get the magnitude, we use the theorem of Pythagoras for what? For vectors that are perpendicular to each other. But for collinear vectors, to get the resultant, we just add F1 plus F2 plus F3. But please make sure that you don't forget the issue of the direction there. Okay? But when you are using the theorem of Pythagoras, the issue of direction doesn't matter there because of a square. Whether you are saying negative 250 squared, positive 250 squared, the answer at the end will be positive. All right. Then, right. So first thing that you need to do, just draw a rough sketch of those forces. So you can see here they're drawn tail to tail. I'm having your Ry acting up, right? I'm having my Rx acting in which direction? To the right. You can see that. Yeah? So it's what we got when we're calculating the resultant of these collinear vectors, okay? Horizontal vectors and the vertical ones, right? So then from there, how do I draw my resultant? Resultant, obvious, it will be a line drawn from what? Or a straight line or a diagonal drawn from what? From two tails to two heads. After completing what? That diagram, the parallelogram, okay? Then what do you do? Now you are looking for the angle. It's either this angle, I can say this is theta, and then or this angle, which is alpha, for example. Okay? I hope it's clear. That is the angle that we are looking for. All right? Either theta or alpha. It can be both. Okay? Then which trig ratio to use? Is it cosine, tan, or sine, right? So in this case, so that you don't get confused, remember it's maths, we understand, but we stick to one trig ratio, which is tangent or tan, right? So tan theta, its opposite side over the adjacent side. Okay, that is tan theta. Okay, same with tan alpha, is opposite over what? Adjacent. Okay, so that is the trig ratio that we use. So it's tan theta for the direction of the resultant for vectors in 2D or for perpendicular vectors. Okay, then from here, this is your theta, right? So which side is opposite to theta? Is this side, which is your ry. So the adjacent is going to be what? Rx. Okay, I hope you are following. Right, so is it which side is opposite to theta? I hope you can see that is ry, the adjacent is rx. But when it comes to alpha, which side is opposite to alpha? Is this side, which is your rx. So it's rx over what? Over ry. Okay, so that is the angle that we are looking for. So there's a question again here, learners. So how do we know when to use the tail-to-head method or tail-to-tail method? It's up to you. If a question says, find the resultant of perpendicular vectors, for example, by means of calculations. So they're saying by means of calculations. So for you to get the angle, either just draw a rough sketch of those forces using the tail-to-tail method or using, so it's up to you. You need to check which one is better to use, right? Which one is suitable to be used, right? So which one do you understand better? So it's what I'm trying to say here, okay? So if they say by means of calculations, so it's either you will use tail-to-tail method or tail-to-head what method. So it's up to you, okay? So remember, it's just a rough sketch. So it's either tail-to-tail or tail-to-head method. You are doing that so that you'll be able to get the angle, right? That is very, very important. So it's either use tail-to-tail method or tail-to-head method. But if a question says by means of calculations, but if they are saying to you, find the resultant of perpendicular vectors, right, by scale drawing. So immediately when they say by scale drawing, they will be specific to say whether you should use the tail-to-tail method or the tail-to-head method. So they will choose for you, right? So tail-to-tail method or tail-to-head method. If they say find the resultant by scale drawing, so they will choose for you whether you should use the tail-to-tail method or the tail-to-head method. But when they say by means of calculations, you are just drawing this rough sketch either using tail-to-tail or tail-to-head so that you will be able to see the angle, right? Okay, I think that is making sense. Ne? So remember, there are two ways in which there are two methods in which we can find what the resultant vector or the resultant force. Okay, so you can either use calculations, or you can find it by means of calculations, or you can find the resultant by means of a scale drawing, or graphically so. Okay, so if they say scale drawing, right, they will give you a scale, right, and then they will also choose the method for you, whether you should use tail-to-tail or tail-to-head what method. I hope it's making sense, right? But if they say by means of calculations, right, obviously you'll use your Pythagoras theorem for perpendicular vectors, all right, get the magnitude. Then from there, to get the angle, I think it's best to start with a rough sketch, right? Either draw those forces using tail-to-tail method or tail-to-head what method, so that you'll be able to see which angle are you looking for, right? So I think it's better that way. But if they say, I repeat again, if they say by means of scale, drawing, right? They will give you a scale. They will choose a method to use. Tail to tail or tail to head method. If they say tail to tail method, this is what you need to do. You need to draw those forces tail to tail. Then how do you draw the resultant? The resultant will be drawn from two tails, right, to two heads after completing the diagram, right? Then, right, what is your RY here? Your RY, okay? Your RY, what is the magnitude? Is 90. And then your Rx is what? Is 215. So 215, 90 divided by 215, you having what here? You are looking for theta, ne? So theta will be 10 to the power negative 1 into 90 divided by 215. Okay? Then you press your calculator. I think what you'll get there is 22.71 what degrees, right? So, but where is this 22.71? Right? Where is this 22.71? It was theta, ne? Which is 22.71 degrees. Then this one is your alpha, right? So your alpha here, you can even say 90 minus what? 22.71, because these vectors, we already know they are perpendicular to each other, ne? So what are we having here? It's 69, 60 what? 7, sorry, point what? 0.29 what degrees. So there's no need to find both angles, right? So just one angle, then you'll be able to give what? The direction. Okay. Then from here, what are you supposed to do? You need to conclude. What is your resultant? Resultant, remember, it's a vector, right? So it has both magnitude and what? And direction. Okay. What is the magnitude? From the Pythagoras theorem or theorem of Pythagoras is 233.08 newtons. Okay? Right? 0.08 newtons, that is the magnitude. Then at 22.71, right? So you can complete your Cartesian plane, right? So at an angle of 22.71, where is this 22.71? It's above the positive what? It is above the positive x-axis. So you can see that above the positive what? X-axis. Above the positive what? X-axis. Or you can use bearing. Right? So bearing, like it or not, for bearing, remember this is the force. Right? Here, what is the angle? Is 69.29. So from north, this is east, this is south, this is west. So you have north here, which is 0 degrees. So from here to here, from north to this force, which is our resultant, then you have 67.29. Then you can say here, the resultant is 233.08 newtons at a bearing of 67.29 degrees. Is it a must to write the direction? Yes, it is a must for us to write what? The direction, right? Unless a question says, give us the magnitude of the resultant force. There's no need there. But if a question says, give us the what? The resultant force. Resultant force, that is a vector. It has both magnitude and what? And direction. Unless if they're going to say, give us the magnitude of the resultant force. So there's no need for you to give the direction. But if the question says give us the resultant force. Resultant force is a vector. It has both magnitude and what? And direction. So you can't forget the direction there. Otherwise, you are going to lose marks. Okay. So that is very, very important, learners. Then, so I think you saw how we do it. Ne? Finding the resultant for what? Perpendicular vectors. First, check if you are having collinear vectors, vectors that are acting along a straight line. Find their resultant, right? Then from there, after finding their resultant, then from there you'll be able to find the resultant of the perpendicular vectors. And the resultant of the perpendicular vectors, you need to use the theorem of Pythagoras to get the resultant of what? Of the perpendicular vectors. So learners, please, you don't just use the theorem of Pythagoras wherever you like, right? It's the theorem of Pythagoras for perpendicular vectors. Perpendicular, it means that those forces, they're acting at right angles to each other, right? So which means that the angle between the two forces, the angle between the two vectors should be 90 degrees. Then in that case, to find the resultant of those two, you have to use the theorem of Pythagoras. And that theorem of Pythagoras, learners, it's only going to give you what? The magnitude. How do we find the direction? Tan theta, right? And before you move to tan theta, first thing, just draw a rough sketch using either tail to tail method, those vectors being drawn tail to tail, right? Or use what? The tail to head method. What is the meaning of tail to head method? Okay, tail to head, for example, here I'm having 90. I can start with this 90 newtons, right? If I draw 215 like this, that is tail to tail, okay? But if now I'm going to join the 215 newtons from the head, right? From the head of the first one, something like this. Now this becomes what? The tail to head what method. So you can see there's a tail and a head where they meet, right? But for the other one, is tail to tail, okay? And how do we draw the resultant here? The resultant, if we are using the tail to head method, the resultant is drawn from free tail to free head. All right? The resultant is drawn from what? From free tail to free head. Hence, the method is called tail to head method. The resultant is drawn from free tail to what? To free head. Then that is the resultant. That is your Ry here, your Rx here, and then this is the resultant using what? The tail to head method. The resultant is drawn from free tail to free what? Head. But if it's tail to tail, you have something like this. This is your Rx, sorry, your Ry. This is your R what? Rx. What should you do? You can see the forces there, or the vectors are drawn tail to tail. Okay? How do you find your resultant? Start by completing what? The diagram where you have your what? Your Rx again up there. You have your what? Your Ry acting up this side. Then how do you draw your resultant? From two tails to two heads. Can you see we are getting the same thing? This is my R here using tail to head. This is my R here using tail to tail. Then the angle, this angle is the same as this angle. If I want to find this one, I can draw a line, complete the Cartesian plane. Then this angle, which is your theta, is your theta here. Your alpha, this is your alpha here. So same thing. So can you explain the part of how bearing works? So the bearing, I will repeat. Bearing, the reference point is north. So your north becomes your 0 degrees. And you move clockwise, right? So from north to east, it's 90. So north will be 0 degrees. And then your east will be 90 degrees. Your south will be 180 degrees. And then your west is going to be what? 271 degrees. Then the full cycle obviously will be 260 degrees, right? So for example, here we got 67.29. Here, 67.29. So from north, this is my north, which is 0 degrees. Here is 90, right? So, but from north to this force, what is the angle? Is 67.29. Ne? Hence, we will say at a bearing of 67.29 degrees. Okay, so that is how we have to find the resultant of perpendicular what? Vectors. Okay, then components of vectors. All right, so when it comes to the components of vectors, this is very, very important, learners, to understand moving forward. resolution of vectors, right? Learners, if in this case now, remember for the previous examples, what we were focusing on? We were focusing on what? On finding the resultant. All right? So you saw that we had our Rx, so Ry and our Rx, and we wanted the resultant here, which is this. Now, you are given the resultant. They want you to find the components. Okay? This is very, very important. So it's like we are given a force here or a vector that is applied at an angle. This is your R now. So now what is it that we are looking for? We are looking for its components, right? And the components is only two components. It's your R your Rx. Now we are moving backwards, all right? You are given this, you are looking for this. Before, you were given this, you were looking for this, which is your R. But now we are given R, you are looking for your Rx and your what? And your Ry. It's what we are looking for, okay? So first thing that you need to do here, you need to resolve that resultant into its what? Components. So what are the components of the resultant? Is the Ry and the Rx. Okay? There is Ry and what? And Rx. Those are the components of R. Okay? Those are the components of the resultant vector. Okay? So resultant vector components is Ry and what? And Rx. Remember, your Ry is the resultant of the vertical forces, right? Your Rx is the resultant of the horizontal what? Forces. Your R is the resultant of these two perpendicular what? Forces, which is your Ry and your Rx, or these two components, which is your Ry and your what? And your Rx. Okay, so now we are moving backwards. So what are you supposed to do? First thing, you must be able to resolve what? A force. So here, when we talk of vectors, let's focus on the forces. Okay, so that is our focus. Let's not just talk about vectors. Let's now be specific. Which vector are we referring to? We are referring to forces. Okay, but R, it accumulates all vectors, resultant of all vectors. Ne? This is the resultant of the horizontal vectors. This is the resultant of the vertical what? Vectors. But now, let's stick to forces as our vectors. Okay? Which means that here I can have what? Resultant force. Right? And then this here, if this is a force, this will be what? Resultant force, which is F res. Here we'll have what? Fy, and then here we'll have what? Fx. If these vectors that I'm referring to is forces, then this will be resultant force, vertical component of the force, and then horizontal component of that force, which is your F res. So now we are moving backwards. Where are we supposed to start? This is very, very important. Okay, so let's look at this. You are given a P. So this is Fp, this is F what? Fq. Okay? So first thing that we need to do here, we are looking for what? The components of these two forces. So you can see this force is applied at an angle to the horizontal. Ne? So first thing that you need to do is to resolve this force into its what? Components. So let's resolve. I have this force, which is P. Right? Then I need to resolve tail to tail. Let's not forget. It's F what here? Fy, and then this one is going to be what? Fx. Okay? This is your Fy, and then this is your what? Your Fx. So what is important here is like, for you to be able to resolve, you must understand how tail to tail method works. Okay? For example, before we were having something like this. Okay? How are we going to draw our resultant? Complete the diagram. Right? Then your resultant from two tails to two heads. All right? So which means that if I have something like this, right? Here I must have the head. Have again what here? The head. Because I know if I'm using tail to tail method, the resultant is drawn from two tails to what? To two heads. So I'm having something like this, all right, which is my resultant. It means that here I must have what? The two vectors drawn tail to tail. So that when I complete the diagram, you see, I'm able to complete it. Okay? So it means that if I can do something like this, okay, this is what I have, right? Then I do something like this. Yes, I'm saying to you, it's drawn tail to tail, something like this. So I've resolved incorrectly so, right? What am I supposed to do? This, that, so that when I complete the diagram, I'm able to do this diagram. The parallelogram what? Method. Okay? So let's resolve this 250 into its components. So it's going to be what? Your f y and your what? Your f what? Your fx. So I will have something like this. I'm having what? Fy and what? And fx. And then this is my what? My resultant force. Okay? Then, what is the magnitude here? Is 250 newtons. I don't know this one. I don't know this one. But I know the angle to the horizontal is what? Is 10 degrees. Which means that here is going to be what? 80 what? 80 degrees. So this is what I have. Then how do I find the magnitude of Fy now and Fx? Okay? So to find the magnitude of Fy and Fx, we have to use the trig ratios again, right? But now which trig ratios? So that you don't get confused. Remember, to find the direction of the resultant for vectors in 2D or for perpendicular vectors, okay? What do? We use tangent, tan theta, then we'll be able to get the angle or the direction there for what? For the perpendicular vectors, right? But to get our fx and our fy, simple, okay? Trig ratios again. Remember here, I'm having 10. So if I can complete here, this is still my fy, and then this is still my what? My fx, okay? So my fy, all right? Okay, let me just do this so that we understand this. Where is it coming from? So that you don't get confused. Sine theta, we are aware that sine theta, its opposite side over the hypotenuse side. I hope I'm correct. Okay? Sine theta, ne? Then cos theta is adjacent so here it should be what? Adjacent side over the hypotenuse side. Okay? Then if my theta is here, right? Because the focus, I think it's better if we're going to do this. Our focus should be the angle to the horizontal. This angle. Let's forget about the angle to the vertical. Angle to the horizontal. So that we stick to one thing. Okay? So this is the theta that I'm talking about. Okay? Which is the angle to the horizontal. And what is the magnitude of this theta? Is 10. So it's sine what here? 10 degrees. Okay? Which side is opposite? Is Fy. What is opposite to that 10 degrees? Is Fy. The hypotenuse side is F res. Okay? This side, which side is adjacent to 10? This is going to be what? Cos what? 10 degrees. Which is going to be what? What side is adjacent? Is Fx. Over what? Over the hypotenuse side, which is F res. Okay? What are we looking for? We are looking for Fy. So let's make Fy the subject of the formula. Fy will be, right, F res, right, F res sine what? Sine 10 what? 10 degrees. Fx will be F res cos what? Cos 10 what? Cos 10 degrees. Okay? So I just want to show you where is this thing coming from. You see this? Okay? So to calculate what? Your Fy. Fy is given by what? F, which is this force or the resultant, what? Sine what? Sine theta. Which theta? The angle to the horizontal. Your Fx is given by what? By F cos what? Cos theta. What is this theta? Is the angle to what? To the horizontal. So that is how we need to find our components, the horizontal component of a force and the result what, and the vertical component what, of a force. Very, very important. Okay, so now we are moving from resultant to components. All right, so first thing that is very, very important, you must be able to resolve that force into its what? Components. Okay, resolve that force into its what? Components. Then if you are able to do that, then the calculations are very, very easy to do. Right, so first thing, make sure that you are able to resolve that force into its what? Components. Okay, so we have resolved this force into its what? Components. Ne? Then, so what are they looking for here? They want us to calculate the horizontal and the vertical components of what? Of P. So this is our P, which is 200 and what? 250 what? Newtons. So first thing that we need to do, resolve it into its what? Components. So this is our P, resolve it into its components. This is my Fy, and then this is going to be what? My Fx. What is the angle here? It's 10 what? 10 degrees. What is my Fy? Fy is given by F what? Sine what? Sine theta. You already know where is this thing coming from. It's not from the atmosphere, ne? So you saw we are using the trig ratios. Okay? Then what is the magnitude of F? Is 250. Sine what? What is the angle to the horizontal? Is 10 what? 10 degrees. Okay? Then what is 250? 250 sine 10 degrees. I'm getting what here? 43.41 what? Newtons. Okay? Then what is the direction of Fy? You can say it's upwards. It's acting up, ne? Upwards. Okay? Then what is your Fx? Your Fx is given by F cos what? Cos theta. What is F? Is 250 cos what? 10 what? 10 degrees. So 250 cos what? Cos 10 degrees. I'm getting 200 and what here? 246, ne? I'm getting 246 point what? 0.20 what? Newtons. In which direction? To the left. Or you can say north here. Here you can say west. Okay, so those are some of the things that are very, very important here to do. Okay, so calculate the horizontal component and the vertical what? Component of what? Of vector P. Right? Simple to calculate the components, but calculation is not a problem. Right? What is important? You must be able to resolve correctly. Right? You must be able to resolve correctly. Right, then let's look at the other one, which is this one. Okay, for Q. Q is like this, right? The angle here, let's check the angle. The angle is 35. 150 is the magnitude. So Q or FQ is given by what? Is 50 what? Newtons. And what is the angle here? Is 35. Ne? But first thing that we need to do is to resolve. How do we resolve? This will be your Fy, and then this will be your what? Your Fx. How are you going to see whether you have resolved correctly or not? Complete the diagram. right? Oh, this is still my fx. This is what? Still my what? My fy. Okay, right? Then from here, this resultant, remember we're using tail-to-tail method. This resultant must be drawn from 2 tails to 2 heads. And it's like that. You can see that, ne? Which means that you have resolved correctly. So this is your fy, and then this is your what? Your fx. So will there be a question where the magnitude does not have an angle? Where the magnitude does not have an angle. Okay, so remember when it comes to vectors, ne, it should be magnitude and what? And direction. Okay, so now please repeat your question. I think you have missed something there. Will there be a question where the magnitude does not have an angle? Or maybe you're trying to say, will there be a question where the answer will be the magnitude only? Yes, you can have such questions, ne? But since we are dealing with vectors, get used to both magnitude and what? And direction. Right, so here, the angle here is what? Is 35. How do you calculate your fy? Fy is what? It's f sine what? Sine theta, which is going to be what? 150, that is fq, right? And then sine what? What is the angle is what? Is 35 degrees. Then you'll get your answer in what? In newtons, right? Then your fx will be what? F sine what? Sine theta, okay? What is your f? It's 150, not sine, but cos for fx. What about that? Cos, ne? So it's cos what? 35 what degrees. Then you'll get what? The components. Okay? Components of what? Of q. Okay? Then from here, you can see that you have your fy for an fx for what? For q. You have fy and fx for what? For p, ne? So in total, how many components are you having now? There are 4. All right? So here, it's like you're having these 2 forces, okay, that are acting on this what? On this object. And you want their resultant. So if you want their resultant, you can see that these 2 forces that are applied at an angle, right? So first thing that you need to do, resolve, right? Each force into its what? Components. Okay? Resolve each force into its what? Components. So you have resolved for what? For your q, and then you also have resolved for your what? For your p. This is p, which is your fy, and your what? Your what? Your fx. Okay? So how many components are acting on this object? You have your fy, which is this one, for q, right? You also have your what? Your fy for what? For p. Okay? Fy for p. You have fx, which is this one, for q. You have this fx for what? For p. So how many components are you having on this object? 1, 2, 3, 4, right? Then already you have calculated the magnitude of this. You have calculated the magnitude of this. Remember, you want the resultant for those 2 forces, your p and q. First thing, because the forces are applied at an angle, first thing, resolve each force into its what? Components. Then from there, calculate the magnitude of each component. We have calculated fyp, fyq, fxq, fx what? Fxp, right? So then you can see that your fyp and your fyq, they are collinear. They are acting along a straight line. So what is it that you need to do? You find their resultant. Okay? You can see your fxp and your fxq. They are also collinear, right? They are acting along a straight line. You can find their resultant. At the end, we are going to have something like this. you have your what? Your F what? Fy, right, for these two. And then maybe you'll have your Fx for these two. So you're left with only two components. And how do you find the resultant? You use the Pythagoras what? Theorem. So it's the same thing as what we did there. But now, what is important is to start by resolving each force into its what? Components. Because now forces are applied at what? At an angle. Resolve each force into its components, calculate the magnitude of each component, and then from there, Fy and Fyq and Fyp, they are acting along a straight line. So you can get their resultant. Ne? And then Fxp and Fxq, they are acting along a straight line. You can get their resultant. And then you'll end up having something like this. Then from there, use Pythagoras theorem to get the magnitude of the resultant. Use tangent or tan theta to get what? The direction. Then from there, you are done. You have calculated what? The resultant of these two forces. Ne? So I think you learners, you understand the method. You have these two forces. I need to explain this again. You have these two forces, this one and this one. You want to find the resultant of these two forces. You cannot just say P plus Q. There's no way. Why? Because they are not along a straight line. You can't say P plus Q unless if they were like this. Then they're along a straight line. I can say this plus this and then take into consideration the issue of the direction. Okay? But in this case, you can see they're not along a straight line, right? They're applied at what? At an angle. So immediately when you see a force that is applied at an angle, what is it that you need to do first? Resolve that force into its what? Components. Okay? And the components, please be careful, right? Resolve correctly. So I've shown you how to resolve. So for example, this one, this is what we have. I'm just recapping on what we did. And then this is what we have. So you have your Fy and your Fx for this force. You have your Fy and Fx for this force. Then from there, find the magnitude of each component. Fy for this, Fx for this. Fy for Q, and then Fx for what? For Q. Then from there, you'll find that Fy's, right? They're acting along the straight lines. The straight line, right? Then from there, what should you do? You have to find their resultant. Fx's, right? They're acting along a horizontal straight line. Find their resultant. Then at the end, you will have only two forces that are perpendicular to each other. Then from there, how do you find their resultant now? Use Pythagoras theorem because they are perpendicular. You'll get the magnitude. How do you find the angle? Use tan theta. And then from there, you will get the resultant for these two forces. You may think this is simple. It's not simple, right? But where do we start? If a force is applied at an angle, resolve that force into its components. From there, calculate the magnitude of each component. From there, check if you have collinear forces of components. If you have collinear components, what are you supposed to do? Find their resultant until you are left with only two forces that will be perpendicular to each other. Then from there, use Pythagoras theorem to calculate the magnitude of those two forces. Use tan theta to get the angle, and then after that you will have the resultant of the perpendicular vectors. I think for today we have to stop here. I think we have done a lot. Then come next week we'll continue with the resultant force, but the focus will be more on closed vector diagram, which is what I have here, and then this will be for next week. I think for today we have done a lot, and so that we don't get confused, So thank you so much for watching this lesson. I hope you have gained something. See you next Friday. Bye bye.